Students, today we shall study motion of a charge in uniform magnetic field. Let us consider a charge Q enters a uniform magnetic field B with velocity v. Magnetic field is applied normal to plane of paper inward shown by cross. So the force acting on the charge will be normal to the direction of velocity, that is towards center. The force is perpendicular to velocity. This force is given by F is equal to BQV sin theta, or we can say F is equal to BQV since theta is equal to 90 degree. Student, this force is perpendicular to velocity. When the force is perpendicular to velocity, the magnitude of velocity remains same, but direction changes continuously. That's why the charged particle moves in a circular path, because when force is perpendicular to velocity, the particle moves in circular path. To move in circular path, the particle will require a centripetal force, that is F is equal to mv square upon r. This centripetal force is supported by force of magnetic field, that is mv square upon r is equal to bqv, or we can say radius of the circular path is r is equal to mv upon bq. The time taken by the charged particle to complete one revolution is called time period, that is time period t is equal to 2 pi r upon v. Substitute the value of r, you will have t is equal to 2m pi upon bq. So the time period of a charged particle is given by t is equal to 2m pi upon bq. Frequency of revolution is equal to reciprocal of the time period. That's why nu is equal to 1 upon t is equal to bq upon 2m pi. Students, very important thing, remember that in this topic there are three pairs of vectors which are perpendicular to each other, that is force and velocity, velocity and magnetic field and force. Now the question is that if velocity is not perpendicular to magnetic field, suppose velocity enters the magnetic field making an angle theta with the direction of magnetic field, then in this case velocity can be resolved into two components, that is v cos theta and v sin theta. V sin theta is perpendicular to magnetic field. That's why the charged particle will move in circular path, and due to the horizontal component v cos theta, the particle will also move horizontally. Charged particle is moving in circular path, side by side in horizontal path also. That's why the path followed by the charged particle will be of helical shape, the radius of which is v sin theta. V sin theta is perpendicular to magnetic field. That's why the radius of this helical path is given by r is equal to mv sin theta upon bq. The expression for time period and frequency will remain same. Only the radius will change, and it is given by r is equal to mv sin theta upon bq. The horizontal distance covered by the charge in the time it completes one revolution, shown by this dotted line, is called pitch. So pitch is equal to horizontal velocity into time, that is v cos theta into 2m pi upon bq.